is Flash Isaac, and I'm a teacher from the future. Temperature. Anytime you see temperature, there is something else that comes to mind. It is referred to as heat. Heat. This is why most textbooks will choose to treat heat and temperature together. They may sound the same, but ladies and gentlemen, there is a big difference, a big dichotomy, a big disparity, a big discrepancy between heat and temperature. The first thing I will say is that temperature is a property of matter. Every matter will have this temperature. While heat is not a property, heat is an energy. Physics is the study of matter in relation to energy. Now, you see that temperature has to do with matter and heat has to do with energy, trying to treat different parts of physics together. Matter is anything that has mass and occupies space. Meanwhile, energy is antimatter. It does not have mass, it does not occupy space. Example of energy is light. And soon we shall be discussing a topic called waves. Waves focuses on energy because a disturbance that may pass through a medium or without medium, and it transfers energy from one place to another. Transfer of energy. Particles in the medium are not moving. Matter exists in three major states: solid state, liquid state, and gaseous state. Example of matter is chalk. For any chalk you see, it is made up of billions and billions of particles. Chalk or matter is built up of so small particles. This particle, or the smallest particle, is called atom. So atom is the unit of matter. Just like if you want to say unit of time, you say seconds or milliseconds. Or the unit of life, you say cell. That is how atom is the unit of matter. So you now, the smallest unit of your body or of anything you see around that are matter is atoms. These atoms are so small that they cannot exist independently. They combine to form molecules. This is chlorine atom. It cannot exist independently. It combines to form Cl2. This is chlorine molecule. So molecules are made up of atoms or an atom, which makes molecule the smallest particle of a substance that can exist on its own or that is capable of independent existence. Atoms are not capable of independent existence. However, they are the smallest particle that can exist. These particles or these molecules, they have what we refer to as kinetic theory. That takes us back to energy. Energy is the ability or capacity to do work. We have different forms of energy: light energy, chemical energy, then we have mechanical energy. Our concern is mechanical energy. Mechanical energy is the energy a body or an object possesses due to position and due to motion. If you are standing in one place, or due to height, rather, if you are at a particular height, any height you are, that energy you possess or that mechanical energy is potential energy. Once you are moving or there is motion, the energy you possess is kinetic energy. So, these molecules, they are in constant random motion. Every particle you have, they have molecules which are moving or which may not be moving. This makes temperature to be measure of the degree of hotness or coldness of a body. That is temperature, a measure of the degree of hotness or coldness of a body. The degree of hotness or coldness of a body depends on how the molecules are moving. If the molecules of an object or of a body or of a surrounding are moving so fast, then the temperature will be high. If the molecules are moving slower, we therefore say temperature is low. If the molecules are not moving, they are standing still, we have what is referred to as absolute zero temperature. And it is temperature where all motion are said to have ceased, or the minimum temperature that is theoretically possible. Absolute temperature is 0 degrees or minus 273 Kelvin. This is absolute zero temperature. Heat, on the other hand, is a form of energy which occur due to temperature difference. So heat is a flow of energy. If there is fire there, you are here, you put your hand here, you feel hot. Why? The heat is coming to you. And why the heat? Because of temperature difference. If you put an object here and there is another object here, if this object is hotter than this one, heat will flow from the hotter object to the cooler object. Now, if you have a hot water and the environment is cold, the water after a while will get cold. Why? The hot object loses heat to the cooler object. So heat will naturally flow from hotter object to cooler object. That is the law of thermodynamics. Now, the unit of temperature is degrees Celsius, Kelvin, or Fahrenheit. For gases or in gas laws, temperature is best measured in Kelvin. If you are given temperature in any other scale or unit, you must convert to Kelvin. How do you convert to Kelvin? You simply add 207 to 3. Something else. The unit of heat is joules. Heat is measured in joules. You can see they are basically not the same thing. Something else, that the instruments used to measure temperature are referred to as thermometers. These are instruments for measuring temperature. Now, these instruments, they have various substances in them or materials in them. And these materials are referred to as thermometric substances. This instrument detects or measures temperature depending on the property of these substances used to make them. By the way, there is a lot on the board. If you can't see this board clearly, it's either you downloaded a low quality version from YouTube or you are streaming it on YouTube in a low quality. YouTube gives you option to increase quality. So just click on the video, you see small settings. Use it to raise the temperature, to raise the quality to 720p or 1080p. You will see everything crystal clear the way I recorded it. The thermometric substances are mercury, alcohol, all gases, platinum wire, thermocouple, and radiant energy. These are the various substances or materials that help thermometers to detect or read temperature. To understand these substances or these thermometric substances, we need to look at the various types of thermometers, the various types of instruments used to measure temperature. We see the substances used in them and the principle these substances depend on. The first we shall be looking at is the gas thermometer. Gas thermometer. Gas thermometer works based on the principle that pressure changes with temperature. Pressure changes with temperature. So the pressure of a fixed or given mass of gas is directly proportional to its temperature, provided dash dash is constant. In gas thermometer, the volume is kept constant while the pressure and temperature vary. And the substances used in gas thermometer are obviously gases. Why do we use gases? We use gases simply because of their expansion. Gases expand and contract. With that, we are able to measure temperature. Gas thermometer is actually bulky. Yes, it is so accurate, but it is bulky. It is difficult to use due to constant correction, and it is slow to use. Nevertheless, it is used for sensitive and accurate work. It requires a perfect gas as standard. Now, we know that gases are not perfect. At low pressure, gases will choose to respond, will behave like ideal gases at low pressure. But when pressure goes very, very high, you see normal gases, they deviate from this ideal condition. So, since this requires a perfect gas, we don't have perfect gases. However, we use gases like hydrogen, helium, and nitrogen. Hydrogen and helium are very, very okay. However, helium is preferred as a thermometric substance in gas thermometer. And the gas thermometer is used as standard for every other thermometer that you will see. To measure temperature using gas thermometer, you use the formula. The temperature you are looking for, C minus 0 over 100 minus 0 is equals P1 minus P0 all over P100 minus P0. Here you need pressure at 100 degrees Celsius, pressure at 0 degrees Celsius, pressure at 0 degrees Celsius, or initial pressure. Then you need the final pressure. These are what you need to answer questions like this. We shall look at questions. The next we have is liquid in glass thermometer. Liquid in glass thermometer, we obviously make use of liquids as thermometric substances. And the liquids used are mercury and alcohol. Mercury and alcohol are used as thermometric substances. However, one of them is preferred. Which of them is preferred and why? Mercury is preferred to alcohol in glass thermometer because 1. Mercury has low thermal capacity. It can detect little quantity of heat. 2. Mercury does not vaporize. Meanwhile, alcohol can vaporize. It is a very good conductor of heat. Mercury allows for wide range of temperature, and mercury is transparent, so you can easily see the temperature change or the change in temperature. When temperature rises, alcohol and mercury, they both expand, with alcohol expanding the more. When temperature drop, both mercury and alcohol, they contrast, with alcohol contrasting the more. Now, liquids in glass thermometer, examples are mercury or alcohol in glass, or clinical thermometer, or minimum and maximum thermometer. Clinical thermometer is under liquid in glass thermometer, and it is used to measure body temperature. It is used at home to measure the temperature of the body. It has low range of temperature. It can be used to measure 35 to 43 degrees Celsius, which is the normal human body temperature range. The minimum and maximum thermometer are used to measure the weather. Let's say temperature of the weather. Let's put it that way. And anytime you are given liquid in glass thermometer, the formula for such calculations is C minus 0 over 100 minus 0 is equals F minus 32 all over 212 minus 32. That is the formula for liquid in glass thermometer. Write all these formulas down so that when you see questions or when we are calculating, it will be applicable. Next, we have the Thermoelectric thermometer. Thermoelectric thermometer work on the principle of changing EMF between two metals, and it is faster than gas thermometer, and it is more accurate than every other thermometer you can see except gas thermometer, which means comparing thermoelectric thermometer with gas thermometer, thermoelectric is faster than gas, but gas is more accurate than thermoelectric. But thermoelectric thermometer is more accurate than every other guy apart from gas. And it is used for measuring varying temperature. Which of the following scale or thermometer is used for measuring varying temperature? It is thermoelectric thermometer, and it can be used to measure the temperature of the aeroplane wing immediately the aeroplane lands. Formula for thermoelectric thermometer is C minus O over 100 minus O is equals E1 minus E0 over E100 minus E0. And remember, it works based on the principle of changing EMF of metals. So platinum would work here. We have bimetallic thermometer. It works based on changing the expansion of two metals with temperature. You are given two metals. How this one and this one respond or change to temperature. That is the principle of bimetallic thermometer. We have the optical pyrometer. It is used, or the principle it works on is variation of light intensity with temperature. That is radiant energy. How light intensity varies with temperature. That is the thermometric property of optical pyrometer. And they are used for measuring very high temperature. Which of the following instruments is used for measuring very high temperature? Optical pyrometer. They can measure above 2000 Kelvin, which all these other guys cannot measure. And we have the resistance thermometer. The resistance thermometer works on change in resistance of pure metals. And the thermometric substance used is platinum wire, which works on change in resistance. And it is used for relatively high temperature, at least than some of these guys, except for optical pyrometer. Since it works based on resistance, the temperature is C minus 0 over 100 minus 0 is equals R1 minus R0 over R100 minus R0. It is very large in size and it responds slowly. These are the setback of resistance thermometer. It is about time we look at questions under temperature and its measurements. Before then, how about to look at qualities of a good thermometer, the features of liquid in glass thermometer, and how to increase the sensitivity of thermometers. A good thermometer must be accurate. It must be sensitive to changes. Once there is change in temperature, the thermometer should be able to adjust or detect the new temperature. It should have low thermal capacity. It should be able to detect little change in heat or little heat. It must be reproducible. Reproducibility is the ability for you to measure a particular temperature more than one time with a thermometer and get the same result. So you should be able to reproduce that result, or to get another thermometer to give you exactly the same result. And it must be suitable for the condition and temperature you are measuring. Then finally, a good thermometer must be consistent. Consistency is another property or feature of a good thermometer. Now, for liquid in glass thermometer, the features are: it must have a capillary tube, it must have a glass bulb, and it must have a thermometric liquid. The thermometric liquid used in liquid in glass thermometer is obviously mercury. And the mercury, it has high expansivity, so it is used to increase sensitivity. There should be liquid of high sensitivity, the glass bulb should be large and thin, and the capillarity tube should have a thin wall and should be narrow. Roman figure 1 use a liquid with a high melting point. Roman figure 2 use a liquid of high volume expansivity. Roman Now figure 3. Use a capillary tube of large diameter. Which of the above best describes how the sensitivity of a liquid in glass thermometer can be enhanced? A liquid in glass thermometer works based on change in volume with temperature. So, to enhance the sensitivity of liquid in glass thermometer, we should use a liquid with high volume expansivity. I think I mentioned it here. Yes, your thermometric liquid should have high expansivity. Option C is the correct option. And the next question says, clinical thermometers are examples of dash. You see that under liquid in glass thermometer, I measured mercury or alcohol in glass, I measured clinical thermometer, and I measure minimum and maximum thermometer. So, liquid in glass thermometer or a clinical thermometer is an example of liquid in glass thermometer. And the liquid used in clinical thermometer is mercury. So, therefore, a clinical thermometer is an example of mercury in glass thermometer. Looking at option A, there is nothing like alcohol thermometer. No, you either say alcohol in glass thermometer or mercury in glass thermometer. Alcohol thermometer itself is not correct. So option D is the correct option here. And a clinical thermometer is different from other mercury in glass thermometer owing to dash. It is owing to the constriction of the stem. Option C is the correct option. And here we have a question. The thermometric property of a thermocouple is change in dash. Looking at this thermoelectric thermometer, you notice that the thermometric property is change in EMF. And what is EMF? Electromotive force. So change in electromotive force is a property of a thermocouple, and that is thermometric thermometer. Electromotive force, EMF. The pressure of a constant volume thermometer at ice point is 325 millimeter of mercury, and at the steam point is 875 millimeter mercury. Find the temperature when the pressure of gas is 490 millimeter mercury. Pressure of a gas of a constant volume thermometer. They already told us that it is a gas thermometer and a constant volume thermometer. So this is obviously a gas thermometer. And gas thermometer works based on pressure change in pressure. And I told you the formula for gas thermometer is C minus 0. That is just C over 100. Because the temperature we are looking for minus 0 is the temperature. And 100 minus 0 is 100. This is P1 minus P0 over P100 minus P0. Now it says at ice point. At ice point, temperature is 0 degrees Celsius. And it says at steam point. Steam point is when water is already boiling, changing from liquid to gas. That is 100 degrees Celsius. So instead of saying 0 degrees Celsius, they said at ice point. And instead of saying 100 degrees Celsius, they said at steam point. So looking at this carefully, this is it. The pressure at ice point is P0. P0 is equals 325 millimeter of mercury. The pressure at steam point is P100. P100 is equals 875 millimeter of mercury. Now find the temperature when the pressure of gas is this. This is the temperature we are looking for. And when you say find when the pressure is this, the pressure this is the P1 we are looking for. If they say find the pressure when the temperature is dash, this is the temperature they gave you, and this is the pressure you are to look for. Now, the pressure given is, or P1, is 490 millimeter mercury. Substituting, you have C over 100 is equals P1 minus, we even have P1 self. P1 is 490 minus P0 is 325 minus 325 over P100 is 875 minus P0 325. From here, you'll be able to get your temperature. Now, let's see the next question. The resistance of a platinum wire at the ice and steam points are 0.7 ohms and 1.05 ohms respectively. Determine the temperature at which the resistance of the wire is 0.9 ohms. We are obviously dealing with resistance thermometer. Before then, if you got 30 degrees Celsius here, you are correct. And to convert 30 degrees Celsius to Kelvin, add 273. That will give you 303 Kelvin or 30 degrees Celsius. Here, since we are dealing with resistance thermometer, the formula is the temperature minus 0, the temperature remains, over 100 minus 0, 100. This is equals R1 minus R0 over R100 minus R0. R0 or R0 is the temperature at ice point. R100 is the temperature at steam point or at 100 degrees Celsius. So, from the question, C is what you are looking for. The temperature over 100 is equals R1 is the given temperature, the resistance rather. Determine the temperature at which the resistance of the wire is this. So the given resistance is R1 and that is 0.9 ohms minus R0 is temperature at ice point and we are given ice temperature at 0.7 ohms. So this is minus 0.7 ohms all over. At steam point, the resistance is 1.05 ohms. So you put 1.05 ohms here minus R0, which is also the resistance at ice point, 0.7. Solving that, you should get C to be around 50 ohms or so. Thanks for watching. Your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos. And don't fail to install the Flash Learners application right now for notes, videos, and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the Flash Learners. Bye.